Namaskar मित्रांनो, today we are going to solve a simple numerical based on series circuit. Okay, so the numerical is a coil having resistance of 7 ohm and inductance of 31.8 millihenry is connected to 230 volt 50 hertz supply. Coil means combination of resistance and inductance. Okay, calculate circuit current, phase angle, power factor and power consumed. So first we will try to interpret what is given in a diagram. Okay, so I will draw that coil first. One resistance, one inductor connected to 230 volt 50 hertz supply. So here the resistance value is 7 ohm and L value is 31.8 millihenry. The supply is 230 volt 50 hertz. So whatever supply is there, it is the RMS value. Okay, so what is given? These are the given things. To find, first is current, that is I, then second is phase angle, that is phi, third is power factor, that is cos phi, and fourth is power consumed, that is P. Okay, so these four things we have to calculate. So to find current, we need to find impedance of the circuit. See, the numericals generally having two given quantities and one is unknown. So sometimes you will get voltage and current is given, Z is unknown. Sometimes you will get V and Z, I is unknown. Like that you will get different types of numericals, but they are simple. If you think on it, you can interpret in a diagram. It is simpler numericals. Okay, so now we have to find Z first to get the current I. So how to find Z? Z bar is nothing but R plus J XL. Since R and L are in series, we have to find R plus J XL. So XL how to find? It is nothing but 2 pi FL. So 2 into pi into 50. L is given in millihenry, we have to convert it into Henry. So 31.8 into 10 raised to minus 3. So this will give me XL 10 ohm, and therefore Z bar is equal to 7 plus J 10. It is comes to be 12.21 at an angle 55 degree. Okay, and this 55 degree is nothing but your phi. Okay, so we have got phi over here. Now what is first thing we have to answer is I is nothing but V by Z. You can directly calculate with the help of magnitude, and if you want to consider phasor, you can take V bar by Z bar. Okay, so this answer gives 0.837 ampere, or you can take it as 230 at an angle 0, Z is 12.21 at an angle 55, and this will again give me 18.837. See here, whenever you are doing division, the angles will get subtracted. So 0 minus 55, it will give minus 55. Magnitudes division normal होईल, but angles subtraction will. So 0 minus 55, it will give me minus 55. So this is in phasor form, and this is your normal magnitude form. Next is phi. Already we have found phi as 55 degree, and third is cos phi as cos 55. 0.574, and as it is an inductive circuit, this power factor we can write as lagging power factor. And finally total power P is equal to, either you can do VI cos phi or simply I square R. Both way you can find, it will give answer similarly. Okay, 230 into 18.837 into cos phi is 0.574. So this will give me either this or this. 2487 watts approximately, I am telling, or you can write this as a 2.487 kilowatts. So power is 2.487 kilowatts. we will see one more numerical. Let us solve second numerical. An EMF of 50 volt 50 hertz is applied to an impedance Z1 bar is equal to 12.5 plus J21. An impedance Z2 is added in series with Z1. Okay, this is second case. The current becomes half of the original and leads it by 12.2 degree. Determine Z2. So in first case it is given that Z1 is only connected to 50 volt 50 hertz. So that's why this Z1 is given as 12.5 plus J21. We are converting it to polar form 24.44 at an angle 59.24. See, for division and multiplication we need polar form. For addition and subtraction we need rectangular form. This I1 will become V upon Z1. Now V is reference 50 volt. So 50 angle 0 divided by Z1 bar 24.44 at an angle 59.24. This will give me I as 2.046 minus 59.24 ampere. In case 2 it is mentioned that Z2 is added in series with Z1. So Z1 and Z2 I am drawing in series. Apply it to the same voltage 50 volt 50 hertz. Condition for current is given that current becomes half of the original and leads it by 14.2 degree. So here minus 5 which I have got here plus 14.2, that is the given condition, it leads by 14.2, so plus, and current magnitude becomes half. So I1 bar divided by I1 by 2 at an angle minus 5 plus 14.2. So this becomes 1.023 and the angles will get, see, 59.24 is negative plus 14.2 gives me minus 45.04. So I have got this current I2 which is flowing in this circuit now. Okay, this current I2 I have got which is flowing now in an entire circuit, and that's why if I use this I2, if I use this 50 volt supply, I can find total Z of this series combination. That's why ZT is equal to V by I2. So V is 50 angle 0, 1.023. So that calculation will gives me 48.88 at an angle 45.04. I have to convert this into rectangular form because at the end I have to do the subtraction. Okay, 34.54 plus J 34.59. And now what is total ZT we have found? But what is exactly total Z? It is nothing but addition of Z1 and Z2 in phasor form. So Z1 bar plus Z2 bar, and that's why if you want to find Z2 bar, it is ZT minus Z1. Okay, and that will give me 34.54 plus J 34.59 minus our original Z, that is 12.5 plus J21, and that gives me answer as 22.04 plus J30.59, and in polar form this is 25.89 at an angle 31.66 ohm. Okay, so that is a two case problem. Okay, let us solve one more numerical based on series circuit. A 100 ohm resistor is connected in series with a choke coil. Now this choke coil nothing but small resistance in series with one inductor. Okay, when 400 volt 50 hertz supply is applied to this combination, the voltage across resistance and the choke coils are 200 volt and 300 volt respectively. Find the power consumed by choke coil, also calculate power factor of choke coil and entire circuit. So first of all we will interpret what is given in a pictorial form. Okay, so given is what? 100 ohm resistor is connected in series with choke coil, means small resistance in series with one inductive coil across 400 volt 50 hertz supply. Okay, so I will show the values over here. This is my 100 ohm. This I don't know the value, so this is Z coil I will write, which includes of R and L or R and XL. Okay, so Z coil, the voltages are given 200 volt and 300 volt respectively across resistance and V coil, I can say. Okay, and the total voltage, that is supply voltage, is 400 volt, 50 hertz. What is asked over here? To find power in coil, that is nothing but I square into small r. Okay, then power factor of choke coil. So power factor is nothing but cos of phi coil. Okay, and power factor of entire circuit. Power factor of entire circuit cos phi. So these three things we need to find. Here you can use coil into I into cos of phi coil. So any one formula you can use over here. Okay, now let us solve this. See, we have to check what is given and what can be further found by using the given values. आता इथे आपल्याला Z coil च्या values माहिती नाही आहेत, R आणि XL. So our first intention is to find R and XL, because when you find R and XL, then only we can go for this formula, that is I square R. Even cos phi coil we can find. Okay, so how to find Z coil? If you observe what is given here, 200 volt is given as a voltage drop across resistance, as well as resistance value is given. So from this we can easily find the current flowing in this part, and this current will be same for Z coil as it is a series circuit. So I can find I first, that is total I, which is nothing but VR divided by R. So it is 200 divided by 100 gives me 2 ampere. Okay, so I have got as a 2 ampere. Now if I have got I, if I am having total voltage, I can find total Z. For entire circuit I can find Z, and therefore Z total is nothing but V total divided by I. And what is our total voltage? It is 400 divided by total current is 2, so 200 ohms. But what is Z total? It is nothing but total resistance square plus inductive part. Okay, so R plus R square plus XL square will be your 200, or you can say R plus R square plus XL square will be 200 square. If I solve, this will give me what? R means 100 plus R square plus XL square is equal to 200 square. Or further I can write 100 square plus 2 times 100 into R, so 200 R plus R square plus XL square is equal to 200 square. So this is my first equation. Okay, now similarly for Z coil we can do the calculation, because we know the 300 volt drop across coil, we know the current, we can find Z coil. Okay, so Z coil is equal to voltage across coil divided by current, as current remaining same as it is a series circuit. So 300 divided by 2 ampere give me 150. Okay, but what is Z coil? Z coil is nothing but R square plus XL square in under root is equal to 150, which implies you can write R square plus XL square is equal to 150 square. This is my second equation. If I use this second equation, R square plus XL square is equal to 150 square, and replace this R square plus XL square, I can solve for R. Okay, so I am replacing using equation 2 and 1. What I will get? 100 square plus 200 R plus, instead of R plus XL square I will write this 150 square is equal to 200 square, and therefore R is equal to 200 square minus 150 square minus 100 square divided by 200. Solving further I will get R is equal to 7.5 ohm. So this I have got. Our first question is what? P. P coil is equal to I square into small r. So I we know 2 square into small r is 37.5. So this approximately comes to be 150 watt. If you want to find power factor, that is cos phi coil. For coil, if I draw the phasor and triangle, I will get R here and XL over here. This will give me Z coil and this is my phi coil. So cos phi coil is equal to what? R by Z coil. R is 37.5 and Z coil we have found as 150. So it is 0.25 lagging. Similarly, if I draw phasor diagram for entire circuit, this will be R plus R, this is XL, this will give me Z total and this is phi total. Okay, and therefore cos phi for entire circuit will be R plus R divided by Z total. What is R here? 37.5 plus 100 divided by total Z is what? Total Z we have found as 200. So this gives me 0.6875. Here also it is lagging because circuit is inductive. Whenever there is a capacitor, we have to give leading. Otherwise, for inductive, it is a lagging circuit. Okay. So in this way, you can solve any numerical with different values. Sometimes you will get instead of L there will be C. Sometimes you will get RLC. So you can find impedance at Z is equal to R square plus J XL minus XC or XC minus XL depending upon values of that C or L. So accordingly we will get different numericals with different types of combination. So here we will end with series circuit numericals. Thank you.